Hello, my name is John Barrett from Sustainable Engineering. Today we are visiting Jiva Materials, who has developed a fully recyclable and biodegradable PCB substrate called Soluboard. We'll be interviewing the company's CEO and conducting a few practical experiments to showcase what they do. I'm here at Jiva Materials today, and we're running a little bit of a test on Soluboard PCB substrate. And so what I have here is a sample of a Soluboard substrate, and you can see there the actual base material, and then the solder mask and copper and circuit on the sample here. And we've set up a solubility test. See here, we've heated some water up. That's running at the moment at 95.6 degrees. So I'm just going to drop the board in using some tongs for safety. And we're going to drop that in. And we're going to let that bubble away for 30 minutes and then come back. We've got time-lapse photography to watch as the substrate starts to dissolve. Then we're going to come back and see how that test has gone. And while we wait, let's speak to Jiva Materials CEO Steve Driver to learn more about the company. Right, here today at Jiva Materials with Steve Driver, CEO of the company, and we're just going to do a quick summary of activities that took place at the end of 2024, including some very interesting news regarding UL certification, and then really giving Steve the opportunity to talk about some of the highlights that are on the horizon for 2025, including some technology updates, exhibition attendance, presentations and that sort of thing. So really over to you, Steve.
2024 was a big year for Jiva. I guess the biggest highlight for us, we achieved the UL flammability rating. The other highlights of last year was we finished the year with engagement with 30 OEMs.
Okay.
With a very, very broad mix of technologies. We're working with automotive companies, lighting companies, industrial electronics companies, and some consumer products, various tracking devices for wearable tech and for parcel and pharmaceutical shipments, single-use electronics. We also secured investment. We launched a funding campaign on Crowdcube, which was the first time we've done a crowdfund campaign, and we secured £250,000 of investment on the 31st of December. Brilliant. So it was a very nice end to the year and sets us up for further investment in 2025. So going forward for 2025, what's hot and happening in 2025? Well, we started the year with an additional employee. We've got a new quality manager starting with us. We're also taking on a new marketing manager, and we're going to bolster the marketing activities for 2025. And we've had a technical paper accepted for a landmark event, the Apex conference in Anaheim, California. We submitted a paper for approval at the end of last year, and this week we've just had a notification that we've been accepted. Okay. So I will be presenting that in March of 2025. And the American market's an important market for us. A lot of our inquiries we have are from America. This is the year where we are really concentrating on bolstering our accreditations, getting recognised at IPC, getting further recognition at UL, and then leading into 2026, which we're going to then call our validation year, where we will have our technology validated in the place of use beyond paid pilots. So where we are at the moment, we're very much engaged with OEMs at paid pilot stage. We've gone well past proof of concept, which was really the 2022, 23, 24 years of proof of concept. We're now in very, very good paid pilot territory. We now want to convert some of those 30 OEMs that we're working with from paid pilots into pre-production runs. Okay. And we see that happening towards the end of 2025. And then 2027 is where our business plan should then take us to commercial traction. And we have production orders, and we have a production facility running, making our pre-pregs, making our laminates, and generally penetrating the marketplace. Okay. So got a pretty clear plan. We know what we're doing.
Could you, when we were talking earlier, you mentioned that in addition to the end of life benefits of this particular technology, there are also some kind of, if you shift that left to the design stage, there are also some benefits in terms of carbon footprint of the material at the design and manufacturing stage. Can you just give us an indication of who you're doing that work with?
Yeah, so that's a very good point. So the interest we've got with the OEMs we are working with at the moment is all around the carbon saving that our material offers.
Right.
We, in the design process, we estimated by using the materials and some of the data we had available at the time, we estimated that we would have a 67% carbon saving against the major incumbent, which is FR4.
Yeah.
Obviously, we accept that there are other materials out there, which are SEM1s, FR2s, PTFEs, and but all of our data, we're benchmarking against FR4 because around 70% of the world's PCBs are on FR4. So our what we've done in 2024 is validated that information. We've worked with Portsmouth University, primarily with Portsmouth University, but we've also been working with Glasgow University, and we've now validated that information using Sigma Pro software, and we've got a confirmed 68% carbon saving against FR4. Now, what does that really mean? There is a little bit of confusion with our product. We call it Soluboard, and when Jack invented this product in 2017, he did it with a very simple PVOH polymer with a natural fibre, and then he screen printed some tracking on using additive technology. That was the creation of Soluboard. That dissolves very, very easily, very, very quickly at 90 degrees. Since that time, the product has evolved. We've become now a more industrial product, and we've had to get other flame retardants in. We've had to look at thermomechanical properties of the material, and we're still working with a PVOH polymer. It's a blended polymer. It's a copolymer. It now has additional fillers. It now has different flame retardants. All still fully biodegradable, and still as a base substrate, it is soluble. However, when you start copper cladding it, and when you start adding solder mask and protective coatings and stitching it together with via holes and copper plating those holes, the solubility becomes more difficult. So there's a mechanical disruption needed, maybe shredding, maybe scoring, maybe slicing, and then you get access to more surface area, and you can dissolve the polymer, expose the fibres, remove the copper, remove the gold, and you have a nice clean recycling process. Our plan for 2025 is to work with two new trademarks that we've secured. One of them is for SPCB, which is going to be the soluble PCB product, which may be just for single-sided, and it may be for additive technology. And we're also have a trademark for RPCB, which is recyclable PCB. Our PCB is truly recyclable. We can recover everything, and we can do that without any harmful processing. We can do that without incineration, without landfill. So the polymer can be dissolved, the fibres can be composted, the metals can go to a clean waste stream, and we get a higher value return on the metals. In 2025, 2026, we also expect to develop that process more. And our ideas around the recycling process is to harvest hot water from the cooling presses that are used to make our laminate. So we're not using energy to recycle, we're using an available source of hot water that will then go through a process that will be used to do the recycling. Of course, to get recycling, we've got to get traction, we've got to get material out in the marketplace. We need their scrap, we need their waste, we need their return goods. So probably the recycling the benefits will come 4 to 5, 6 years down the road when product starts getting disposed of. So yes, the focus was all around the validation, so that we can support the Scope 3 directives that our customers are having to report on as we move forward on this sustainable journey.
I didn't know if you wanted to say anything about the soluble ink.
We're engaged with Alarion, and I'm happy to give that a mention.
Yeah.
We're engaged with Alarion, a startup in Wales that have been awarded an Innovate UK money, and we're hoping to 2025 to engage further and have a truly soluble circuit board using soluble silver ink and a soluble PCB substrate. It is on our radar for this year. We're also engaged, so actually let's talk about a few other people. So when we're choosing our suppliers, we're trying to choose suppliers that are working in a similar way to Jiva with a similar mission.
Yeah.
So we've just identified, so one of the things we use during our manufacturing is a release paper.
Right.
And we've now engaged with a company called Techlan.
Okay.
And they use recycled silicon paper. So it's a carrier paper for the packaging industry. Yeah. And then they clean it and they resell it as a recycled silicon paper. Okay. So that's one company that we're aligning with, Techland, for our recycled paper. And then we're aligning with Alarion because they've got this nice recycled silver ink. Yeah. And then the other company that we've aligned with is a company called Lilo Tree. Lilo Tree is an American startup that are using a cyanide-free gold. And we're able to offer that on our product. And this is new for 2025. We're able to offer a gold finish on our product that's nickel-free, because it has a nano organic barrier between the gold and the copper. So again, another green finish that we're adding to our product. So we're trying to align all of our suppliers with our sustainability message.
Okay.
Now let's return to our Soluboard PCB substrate experiment to see how the test has gone.
So we are back at the test 30 minutes after we began. It's 11:15, it's now 11:15, and we're going to have a little look inside the flask at the result of the test. So here we go. So if you come and have a look here, we'll see now that the original board that went in, so there is layer 1 of the reinforcement. That is separated out. There is layer 2 of the reinforcement, and finally we have the copper, if I can get to it, which is proving tricky. There it is, as you can see there. So the actual polymer content of the PCB has fully dissolved, and we now have the 3 key elements, which is the copper and the 2 reinforcement layers, separated. So soluble, dissolved, and ready for final recycling or reuse. Right, so for the second solubility test, we have got a single-sided LED board here. What we're going to do is we're going to guillotine this to take a slice off the board. So have a look in there. And we're going to cut a sample. It's there. And we're now going to drop that into the second flask, leave that for 30 minutes. This is the latest formulation of the substrate, and see how that behaves running the same test. We are back at the test unit. This time we're using the latest formulation. This is the single-sided LED board that we were guillotining earlier. So we're going to drop this into the water, like so. We've got the stirrer in place, keeping the water on the move. Currently we're running at 86 degrees, but the water is warming up. It needs to be around about 90 degrees, so I understand. We'll set the timer running, and we will come back in 30 minutes and see how this test run too.
Again, while we wait for this experiment, let's take a closer look at the Soluboard technology with Steve.
We are looking at the constituent parts of the Soluboard technology. We've got the polymer, we've got the reinforcement matrix, and we've got the copper layer. So Steve, I don't know if you just want to talk us through the rough manufacturing process that these parts would go through to formulate the finished board.
Yeah, so on this occasion we're using a jute fabric. So the jute is a fully biodegradable fabric. We source that from India. We then coat the fabric and make a pre-preg, and then we coat this with our polymer, which has been formulated by Jiva. It's got various fillers in it and obviously a flame retardant to give us our flame retardancy. And then we laminate that in a hot press and coat it with a copper foil. If it's single-sided, we put copper one side, double-sided, put copper both sides. Once it's been made into a copper panel, it then goes off to the PCB fabricator, and that fabricator will etch the copper parts, the copper traces, apply the solder mask. In this case it's white, but in many cases it's green. So that, as you said, John, at the start, that is our constituent parts that make up this laminate.
Okay. And in the first solubility test we ran, when the polymer was dissolved and the components separated, it was a two-layer reinforcement. Is 2 layers your standard?
It's kind of a default. So two layers is so 2 layers of reinforcement gives us approximately a 1.6mm board. Standard FR4 material is manufactured with multiple layers of pre-preg, 7 or 8 layers, and they can hold tolerances of plus or minus 10%. At the moment we're using a natural fibre, and we're using a product that has been manufactured for other uses, for example sacking or brick coverings, and it's not so accurate, so our tolerance is plus or minus 15%. We are at the moment working with a new weaving company, and we will have our own fabric manufactured later in 2025, again using the constituent parts of a natural fibre to create a fabric which is bespoke to Jiva, and we'll be able to make 0.2, 0.3, 0.4, 0.5mm material.
Now let's return to our second test to see how that's gone.
Back at the second test, the sample's been in for about 30 minutes now, so we're just going to see how that has delaminated.
Don't forget to follow Sustainable Engineering to see stories like this as published in our monthly digital magazine.
So let's have a little look. So laminate, reinforcement layer 1. Completely devoid of polymer, and then second out there, which we can see that's now free of polymer, and if I could touch it, you can see there the substrate coming away like so.
As you can see, the substrate is coming apart quite easily as I peel the mask away. That concludes the second experiment. Now let's move on to the final test of the day, a simulation of the flame test.
We're just taking a quick look here at essentially a simulation of the burn test that the laminate has to go through to get the UL rating. So we've got a test strip set up and a burner. And we're going to time that now. That's going to be in the flame for 10 seconds, then removed and self-extinguish, which it has, for 10 seconds. That's 20 seconds. And then back into the flame for another 10. And back out there, and then this must self-extinguish in 10. 6. And extinguished. Right on the button. So we're at Jiva Materials, where we've been here today checking out the Soluboard technology, biodegradable printed circuit boards. For information on this type of technology and other sustainable technologies, please follow sustainable.engineering's website and Sustainable Engineering on LinkedIn.